we are kicking off Unit 2 of Geometry, and this is the unit where if you've ever heard horror stories about geometry, they probably include proofs. Ryan, we're recording. Quiet, please. If you've heard horror stories about geometry, they probably include proofs, and this is the unit where we're introduced to proofs. Okay? Part of geometry is being able to argue competently. You've all been in an argument with someone before who either does not explain their point very well at all, or is so set on what they have to say they don't really offer good evidence. You know, this is my belief, and that is it. It's very tough to have a conversation or very tough to argue with someone who's in that mindset. Okay, so I'm going to teach you this unit to argue competently, which basically means defend what you have to say. Okay, Maddie, can you shut the door, please? I thought we could do it open, but no. They're not being loud, but okay. So, a conjecture is basically a conclusion. Oh, gosh. It's going to be like this. A conjecture is a conclusion based on information available and it is unproven. Okay? A conjecture is a conclusion based on information available and it is unproven. For example, you wake up in the morning, you decide what you want to wear. Obviously, orange pants, pink shirt, great option. But you look outside and you see that it is snowing. Are you going to put on shorts and a short sleeve shirt? I would. Some of you might. Okay, but no, right? Based on the information available, you are making a conjecture in your mind that it is cold outside. Okay, because you've had experience with snow before. Right? You know what snow means. You know what kind of temperature it has to be for it to be able to snow. Is it a proven statement, the conjecture? No, not until you go outside and you feel the weather. Some of you are just fine in shorts and t-shirt outside, right? But the conjecture that you're making, Tristan, is that the weather is cool enough you should put on probably some long pants, a long sleeve shirt, sweatshirt, jacket, whatever it might be. Okay? So you are using what's called inductive reasoning, which is informal reasoning based on patterns or past experiences. I think I have to go yell at the kids out in the hallway. So just a second.
We got kicked out.
I need a PO. It's too bad.
You got the POs.
I tell you to.
Hey guys. Yeah, come here, quick, back.
Video's still recording. You really appreciate it. I know. Yeah, get it over there. He's recording. Ah! Guys.
What are we gonna do, guys?
He's still recording.
Okay, so conjecture, conclusion based on information available is unproven. Inductive reasoning, informal reasoning based on patterns or past experiences. You look outside, you can guess the temperature based on the weather. That's based on patterns. Okay, what season is it? Past experiences, you know what it's like when it rains, when it snows, etc. Right? And a counter example is any example that disproves a conjecture? Okay? Any example that disproves a conjecture? Questions so far? Okay. So we are going to use inductive reasoning to form a conjecture about each situation. And the first one we come across here is a table with a pattern. It says the pattern is how the number of connections increases. If we have 1 point, there's a pictorial representation of it. The number of connections is 0 because there's nothing to connect to. We have two points. Here's a picture, and the one connection that can be made is drawn in there. 3 points, 3 connections made. 4 points, 6 connections made. 5 points, how many connections are there? Okay, and you can either, and we see this with the pattern block questions in your math packets also. That's kind of why they're in there. You can either just count, right, or you can look for a pattern and make a conjecture about what's going to happen next. What do you think the number of connections are for 5 dots? Jocelyn, I saw your hand up first. Would you like to answer? 10. Okay, and you can either count them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, they're drawn in there for you. Or what pattern can you see here? Colin.
+1, +2, +3, +4.
Right, the difference is going up by 1 each time here. From 0 to 1 is an increase of 1. From 1 to 3 is an increase of 2. From 3 to 6 is an increase of 3. So it stands to reason that the next one would be an increase of 4. And that's actually how it works out. Okay, so you make conjectures all the time. You walk into a room, you're making a conjecture about what's happening. You walk into a classroom and it's absolutely silent. Teacher's sitting at the desk. What do you suppose is happening? Could be a test, right?
Just be very
Could be the
Could be very angry. Maybe it's quiet time because the teacher got sick of the outburst and said just silence for everything else, right? But you make that judgment when you meet someone for the first time. Your first impression about that person is a conjecture. Right? You don't know anything about them other than what you're seeing right in front of you. You are making a conclusion based on information available. Right? So you do this a lot. Inductive reasoning, would this be the type of reasoning that a lawyer would want to use?
No.
Probably not. A doctor would want to use to make a major medical diagnosis on surgery or amputation or something like that? No. Okay? This is very, would you want to decide what high school you are headed to based on inductive reasoning?
No.
I'd hope not, right? You want to do a little bit of research, okay? Other ones here. What is a counterexample to each statement below? Remember, a counterexample is something that proves it false. Perhaps a young student who is first learning negative numbers and multiplication might come up to you and say, if the product of 2 numbers is positive, then the 2 numbers must both be positive. That's a conjecture that a student might make based on the information available. However, your counterexample, Leah?
-4 + 6 = 2.
Well, so we're on this first one here. Product would be multiplication, right? So if the product of 2 numbers is positive, the 2 numbers must both be positive. Eli, counterexample.
-4 times -4.
Right. If both numbers are negative, you also get a positive result. So that would be a counterexample. It's something that proves the conjecture false. Okay? If the product of 2 numbers is even, then the 2 numbers must both be even. If the product of 2 numbers is even, the 2 numbers must both be even. This might be something that, again, a young student might say. Brielle.
3 + 5.
So product is multiplication.
Oh.
Okay. Paisley?
2 times 7.
2 times 7, right? 2 is even, 7's odd. The product is even. That would be a counterexample. All functions are a straight line when graphed on the coordinate plane. Who remembers what functions are? All functions are straight lines when graphed on the coordinate plane. Give me a counterexample. A parabola, right? A parabola is not a straight line, yet it is a function because x does not repeat itself, right? An example, just going back to algebra, something that would not be a function would be a graph like this. Okay, the vertical line test, right? Hits it twice, x repeats, that whole thing, right? So, but the statement, all functions are a straight line when graphed on the coordinate plane, that would be a counterexample. What is a common example of you using inductive reasoning to make a conjecture? I've given several. Anything that you can come up with. Tristan. Yeah, anytime you assume something, though, right? That is a conjecture that you're making based on the information available to you. Sometimes when I hear talking and I'm writing on the board and I turn around and sometimes I get the wrong person, okay? That happens. I'm making a conjecture. I'm using inductive reasoning. I'm using patterns. Who do I have to tell to be quiet a lot?
Izzy.
Oh, dang. Wow.
That wasn't even me.
No, but Izzy doesn't deserve it. Izzy doesn't deserve
That's so mean. That's actually so mean.
But you make a conjecture.
That was actually so
If you are always someone who's being told to quiet down, maybe that's because you have the reputation or you have the pattern of being loud. Okay? Whoa, another name drop. Look at all these name drops just happening here. Woo.
Izzy, I said that you don't deserve
No, this is why she was my favorite.
Did you make her go to the hall?
No, I didn't. She was
Half of the time when you tell her to be quiet, it's not her.
because you're on camera doing nonsense.
I was helping with ideas.
3, 2, 1, you are quiet. Maddie, what's an example of a conjecture with inductive reasoning?
You looking at the weather and seeing that it's like 10 degrees out and you decide to wear a jacket.
Yes. Okay. Weather. Paisley.
Looking at Miss Will's facial expression to tell if she doesn't like her outfit.
Ooh.
Oh, dang.
Are you talking for personal experience for yourself?
No, for you.
Colin.
If you're sitting at the homeroom soccer game and your classmates are cheering, that means that
Sounds good. Yeah. Excellent.
Your classmates are cheering.
you would be
You go to school, learn?
You want to bet?
Yeah.
No,
Yeah. Hey, Briggs. Hey. Riel.
Looking at the mirror, realizing you're bald.
Real.
Mr. Schultz, you're gonna have to edit that out of the video.
Charlotte's got the floor. Go ahead, Charlotte.
Looking at your head and seeing it shiny.
It is really shiny. I saw it in the camera earlier. It's not good. Izzy!
More like bald days.
Izzy?
Wait, and you guys all say Izzy doesn't deserve it.
I'm not the one who's...
Revenge.
Your homework for Monday. Tomorrow's a retake day. Since I took one the last two, I actually gave you one last week. That was serious.
Maybe.
No, last week you were gone.
I am.
Mr. Schultz, are you a sussy baka?
I don't know what that means.
You don't need to know.
On page 75, you are to do 5 through 12.
Oh my gosh.
And that's it? Thank you, Mr. Schultz. That's it.
Comma.
No!
Thank you.
Stop talking when he says that.
32
When you say, oh my goodness, that's not that much.
and 33. And again, that is due on Monday. Don't forget, Ryan, I'm still recording. Nick, Khan Academy is due tonight. Don't sleep on that. Don't forget about that. Only 3 weeks left in the try. Now's not the time to be losing those freebie points. Okay? 20 minutes to work on this. Con can be an option as well. That is how you math.